back at it again with the white vans. We are back with fractions. And today we are talking about adding fractions. So let's get in to the nitty gritty. So first off, I'm gonna pose a question for you. So you're sitting, if we had four adults if we had four adults plus one adult, how many adults do we have, right? So we have four adults. Hey, I'm an adult. Plus one adult, right? So here's four. Right, that one's a little weird. I don't know what's going on. It's like he's running. Hey, I'm an adult. Plus one more. And this guy, he has cool hair. And muscles. Hey, I'm strong. And a smile. And how many do we have? If you said 5 adults, that would make complete sense. But what happens if instead I say, well, we have one child and 3 adults. Hey, there's the dude with the cool hair and the muscles. Can we do that? And if you're saying, well, not really, we can't really add those two, it would be 3 adults and a child. That's how we would say that. Well, the same thing goes with fractions. So I want you to think really quick, like, how can we make this work? Well, what if we changed all of them to people and we had 3 people plus one more person, right? Plus one more person, we would have 4 people, right? So equals 4 people. We could leave it the way it was, one child plus 3 adults, but we wouldn't be able to do anything with that. We can't add that because they're not the same units. So in this case, we call it, well, there's 3 adults and a child, or there's 1 child and 3 adults. But if we change all of them to the same units, 4 people, 3 people plus one person, or 1 peoples, depending upon where you're from, we can combine them and make it something that we can work with. And that's the same thing we're going to do with fractions today. So let's take a problem. I'm just going to show you this. Say hi. Oh, say bye. So we're going to take a problem here. And so what happens if we have 2/3 plus 1/4? I want you to go back and think about how we did equivalent fractions, and this is really going to come into play. We have something called unlike denominators. Now the denominator is on the bottom, the numerator is on the top. We know this from past experiences, and if we don't, the denominator is on the bottom and the numerator is on the top. So we have something called unlike denominators, meaning they're not the same. We have a 3 and we have a 4. We can't add them together. They're different. And we want to take that same idea of having 1 child and 3 adults and applying it to fractions. So here I have my 2 boxes. Let's draw ourselves a picture. And in order to do this, I'm going to draw on my knowledge of equivalent fractions and just draw what I have. So remember, it's part of a whole. Here's my 2/3. Here's my 1/4. I'm going to draw my 4ths like this. I'm going to draw them sideways. And you'll see why in a second. So, and then I'm just going to color them. So 3/4, there's 1/4, 2/4, 3/4, and here's my 2/3. Now, I want to make it so that I can add these together. Some of you have probably already seen this in the picture. And some of you may already have the knowledge as to what is the common denominator between those. Common meaning the same. So if this is in thirds and this is in fourths, can I not just split this one into fourths and this one into thirds and see what happens? So let's try that. So I'm going to split this into fourths because this one's in fourths, right? And then I'm going to split this one into thirds. And now, do we not have the same amount of boxes? Right? We do. And so looking at this, let's start adding them up. Okay, we want to add both of these. Oh, and you know what I did wrong? You're probably already seeing this. I said 3/4. This is 1/4. So maybe you're like, Mr. Luke, this is so wrong. Yeah, it is. So let's fix that. Here we go. I'm going to fix this right now. See ya. So really, oops, we had fourths, right? Because we started with 1/4. My bad. I don't know how I had 3/4 in my head. Sometimes it's a mistake. Mistakes. Remember, we learn from our mistakes. Maybe you were looking at that mistake and like, I know how to do this. Great. So you're going to take this and split this into thirds. So now look at, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Whoops, I miscounted there. 3, 6, 9, 12, right? 4, 8, 12. Okay, so we have 12 boxes. And in this one, 2/3 of the boxes would add up to 1, 2, 3, 4, 5, 6, 7. I'm sorry, 8. What am I doing? 2, 4, 6, 8, right? And then this is 1, 2, 3. So this is 8/12, right? And this is 3/12. And these are common. We've made them the same, right? People versus adults and children. We've made them the same. And so we can add these together, you know? And you could even draw a third box and color in the same amount of boxes and then add them all up. It's going to work the same. So 8 plus 3 is now 11. So our answer is going to be 11/12. So what is 2/3 plus 1/4? Well, it is equal to 8/12 plus 3/12, which is equal to 11/12. And so that's how we would do that, right? So what is happening here? Let me show you. Let's get rid of that. So what's happening is we're finding a common denominator. What is the common denominator between 3 and 4? It would be 12. And so in order to change those, I'm going to change 2/3 to 12. And how do I do that? If you remember, right? You can multiply by, in this case, 4/4, right? And what does that change it to? That's that 8/12. So if you go back and rewind it, you would see that. And what about the 1/4? Well, the 1/4, I'll do it over here. We multiplied by 3/3, which is 3/12. And then we combined them, 8/12 plus 3/12, giving us 11/12. So that's how we would do adding fractions with unlike denominators. It seems really simple. It's even better if you start to understand it and you start to see the pictures. But that's kind of that lesson. In the next video, we'll talk a little bit more about this and what happens if we get a bigger number. And maybe I'll use that 3/4 and we'll come back to it.